Welcome to Video 4, Cardinality Principle. Now we come to the last of the three most important principles for producing an accurate count, cardinality. As you learned in Video 1, this rule involves understanding that the last number word used when counting a set names the total or cardinal amount of the set. As adults, we commonly use the counting procedure, reach the final count word, and move on, assuming the cardinal amount is now understood. But as children are just learning to use the counting procedure, the purpose of counting, to determine a total amount, is often not obvious to them, or at least the purpose is not part of what they're thinking about while they're counting. Recall that children's earliest number knowledge begins with the cardinal sense of amount for very small numbers. Children are first one knowers, then two knowers, and then three knowers, all before they ever learn to count a set of objects. That's why they're able to subbatize these small amounts. As they become familiar with the sequence of the count words, the 1, 2, 3, 4, their first understanding of this word pattern may have very little to do with thinking about how many of any set. And the counting procedure they are trying to learn, as we have seen, is very complicated. It makes sense that children might learn some parts of the procedure first, and then later realize they can link the counting to the threeness and the fourness that they already know. The best way to determine if children understand that a counting procedure has produced a cardinal amount is to use the third key instructional practice for teaching meaningful counting, to ask, how many altogether after children count something? For example, suppose a child counts a small set of crayons as 1, 2, 3, 4. You then say, how many is that altogether? If the child produces the counting procedure again, saying 1, 2, 3, 4, then they are not quite there with the understanding of how the procedure gives a total amount. At this stage, children understand that when someone asks how many, the proper response is to conduct a counting procedure. So they do that, which is great. They just need to be introduced to the naming of the total amount and the thing or unit that was counted as an additional and distinct step. For this reason, the first key instructional practice you learned about, modeling counting, specifically directs you to include statements of cardinal amount. When you model counting, it's important that you don't just stop with the last number in the count sequence. Always say, for example, 3, 4, 5, 6, there are 6 cups. Also, the third meaningful counting practice, asking children how many altogether, is the other key for helping children connect the counting procedure with the meaning it produces. In Video 3, you learn that children can become confused by the complexity of simply coordinating all the counting skills into one procedure. Part of the reason for children's common confusion is the very special nature of the counting words. When we count, the counting words become precision tools that we use in two distinct ways. First, we use the words as tags to mark each item, as in 1, 2, 3. And then we use one of the words not as a tag at all, but as a description of the entire set, as in 3 plants. A young child has no precedent for this way of using words in their language. This is a unique feature of counting words. Because cardinality is so unique and so new to young children, they need many opportunities to hear not just a count procedure being conducted, but to hear it paired with a statement of cardinal amount. Research is clear that when teachers and families pair the counting procedure with a final statement of how many of what, as in there are 5 forks, children more quickly grasp the idea of cardinality. Recall, too, that when a small subbatizable set is counted, children may bring their own understanding of a set's total amount to the counting. That's why being able to subbatize a set of 3 means a child is ready to learn about meaningful counting. For example, when they see 3 instantly, and then hear 1, 2, 3, there are 3 acorns, they have all the information they need to decipher how the counting procedure works. They know it's 3, and then they see that the procedure delivers the same total. Experiences like this help children to believe that the counting procedure is meaningful. It's for this reason that the first key instructional practice for meaningful counting is model counting perceptually subbatizable object sets, that is 1 to 3 objects, using slow, deliberate, 1-to-1 tagging and statements of cardinality. The final key instructional practice for meaningful counting is to vary your counting in 3 ways. First, you can vary the set sizes you count so that children see the counting procedure being used with both small sets they can actually subitize and larger unsubitizable sets. Second, you can vary the things that are counted, not just dots, but also everyday objects like shoes and toothbrushes, sounds, like how often a bell rings or how many knocks at the door, and abstract or imagined things like days or ideas. Finally, you can show children that while counting word sequence always has to stay the same, the objects in the set can be counted in any order as long as each object is counted once and only once. That is, counting from left to right or top to bottom can help you keep track of what you've counted, but this sequence is not necessary for an accurate count. When you count your classroom of 18 students more than once in a day, Joey might be number 3 in the morning and number 12 after lunch. The total will still be 18, and that's what matters. So counting a set twice and changing the order in which you count the objects can be a useful demonstration of how you get the same cardinal amount each time. The cardinal amount has many unique characteristics. It is real whether you can subitize it or not. It can be applied to anything we think or speak of, whether it is tangible or not. And the cardinal amount doesn't change regardless of the order in which you count the objects in a set. These characteristics are profound, and children need many opportunities to think about them. That's why varying set sizes, what is counted, and the order in which you count things will provide children with the evidence they need to wrestle with this important understanding. The last part of the meaningful counting developmental progression gives a clear picture of how children's conceptual understanding of cardinality develops. We see that children much more quickly associate the total amount with the counting procedure for sets less than 5, which they can easily subitize. They need many experiences of counting these small amounts and stating or hearing the total amount, as in 1, 2, 3, 4, there are 4 hair clips, so they can develop a belief in the reliability of the counting procedure. When they finally do generalize the rule that the last word in the count procedure tells the total amount, then they are able to answer the question, how many altogether, for sets greater than 5 that are too big to subitize. One final test of the strength and durability of children's understanding of the cardinality principle is provided by a particular counting task, asking children to count out a set of a specific amount from a larger set. Interestingly, counting the amount of a given set is a much simpler task than creating a set of a specific size. For example, a child who can readily and accurately count a set of 7 pencils and tell you there are 7 altogether may have difficulty getting you a set of 4 pencils from a basket that holds 30. That is because when the set is already created, the child has to focus only on the count procedure. However, when the child has to count out a set of 4 pencils from a basket of many pencils, they must not only focus on the counting procedure, but also remember to stop when they reach 4. The developmental progression for meaningful counting includes these further stages in the development of cardinal understanding to remind you of the difficulty posed by the counting out tasks. Reserve them for when you want to add challenge for a student. Finally, it's worth repeating that the best teaching practice you can implement to help children with the cardinality principle is combining the slow, deliberate modeling of counting we have been discussing in the last 3 videos with a clear statement of the total amount that names the objects counted. The more often you demonstrate counting as 1, 2, 3, 4, there are 4 strawberries, the more opportunities your students will have to achieve this profound understanding of how counting connects to amount.